In this video, I'm going over our second day of adding and subtracting rational expressions. So in the first example, notice in our denominators, right? Remember when adding and subtracting, they have to be the same. Well, here I have a trinomial and the other I only have a binomial, x plus 4. So what we're used to doing here with a trinomial is, well, I could factor this. So if I were to factor this, I could go straight to my parentheses because a is 1. X squared was by itself, coefficient of 1. So I can ask what numbers multiply to give me -4 and add to give me +3. +4 and -1. So really, this denominator is the same as saying x plus 4 times x minus 1. So in this denominator, if I only have x plus 4, well then what's missing? X minus 1. So I need to multiply by x minus 1 to get my common denominator of x plus 4 times x minus 1. So here I'm going to, again, just combine everything together as one fraction. So no changes needed for our first rational expression because it already has the denominator that we're using here. So I'm just going to bring down x minus 3. Then we're adding to that, so I'm distributing a positive because we're adding 2x times x minus 1. So I have 2x times x minus 1. Well, 2x times x is 2x squared. Then 2x times -1, -2x. So here we have positive 2x squared minus 2x over our common denominator of x plus 4 times x minus 1. Now I can continue simplifying because we have like terms to combine. I have no x squared terms, so I'm going to write here 2x squared, but I have x minus 2x, which is now -1, so -x. Then minus 3, no other term to combine this with, like term, over x plus 4 times x minus 1. So this is our expression. Then, of course, for good practice, if I wanted to know here, what are the values that make this undefined? Remember, our denominator is what cannot equal 0. So here you have x plus 4 times x minus 1 cannot equal 0. That means x cannot equal -4 and +1. Go ahead and pause the video and try this. You try here, and let's see how you do. Here we go. So again, I see here I have a binomial, the x plus 3, and here I have another trinomial. So I'm going to go ahead and factor this trinomial to see what I end up with. Well, I could factor this going straight to my parentheses because x squared has coefficient of 1, a is 1. What numbers multiply to give me 9 and add to give me 6? 3 and 3. So x plus 3 times x plus 3. So that means here if I have x plus 3 times another x plus 3, but this denominator is only x plus 3, then that means I need to multiply this by x plus 3 as well. So now here, I'm going to go ahead and rewrite my fraction now, combining all together as 1. But I first need to distribute my x times x plus 3. So I've got x times x plus 3. Well, x times x, x squared, and x times 3, 3x. So here I've got x squared plus 3x. Then the second rational expression already had our denominator that we're using. I'm going to bring down that numerator, plus 2x plus 6 over x plus 3 times x plus 3. Now I can combine like terms and continue simplifying because here I have 3x plus 2x. So this now I have x squared plus 5x plus 6 over x plus 3 times x plus 3. Now, if I wanted to, and this could be my final answer, and then x cannot equal -3 in the denominator. Or for those who went ahead and continued, if I want to continue simplifying, I could see that my numerator could also technically be factored. So this is for those who went ahead and took it a step further. What numbers multiply to get you 6 and add to get 5? 3 and 2. So x plus 3 times x plus 2 over x plus 3 times x plus 3. Then, again, for those who notice this, again, great job. I could simplify because I can cancel out x plus 3 and left with fully simplified x plus 2 over x plus 3. Now let's look at example 2. I notice again in my denominators, right, I have my two expressions here, but this is just a binomial x plus 3. Now, this is a binomial, but I do notice that I have a difference because I'm subtracting of two perfect squares. So this expression here can be factored into x plus 3 times x minus 3 because that is our difference of two perfect squares. So if I can factor this binomial here into x plus 3 times x minus 3, and this denominator is already x plus 3, then that means what's missing? X minus 3. So I'm going to multiply by x minus 3 here. So now I've got here for the first, I'm going to go ahead and bring this down. So because this already had the denominator that we're using, so 2x squared minus 30. Then minus, here now I notice I do have two binomials that are being multiplied. So we do need to do box method with the two binomials. X plus 5 times x minus 3. Here I've got x squared and 5x, negative 3x, and negative 15. Then, of course, combine like terms, which 5x minus 3x is now 2x. Here I've got x squared plus 2x minus 15 over x plus 3 times x minus 3. But before I can start simplifying and combining like terms, make sure, because we have subtraction, I need to distribute that negative or negative 1 here. So really, we're going to be combining 2x squared minus 30 minus x squared minus 2x, and not minus 15 anymore, but plus 15. So with combining like terms, I have 2x squared minus x squared minus 1x squared, which is now just 1, so x squared. There's only this one x term here, so negative 2x. But we do have negative 30 plus 15, which is negative 15 over x plus 3 times x minus 3. Then I could actually continue on and simplify this even more if I wanted to, because this trinomial I can factor into what numbers multiply, give me negative 15 and add to get you negative 2, negative 5, and positive 3. So if I have this expression factored form, right, over x plus 3 times x minus 3, now you notice, well, what still cancels out? The x plus 3's. So fully simplified is x minus 5 over x minus 3. Go ahead and pause the video here and try this try on your own. And with this problem, I see again two binomials. However, this is just x plus 8 in the second rational expression. And this is a difference because we're subtracting of two perfect squares. So when I take the square root here, I could factor this into x plus 8 times x minus 8. Then here, because this can be factored into x plus 8 times x minus 8, and now here I have my x plus 8, what's missing? X minus 8. So this is what you need to multiply by, x minus 8 here. Then I'm going to go ahead and bring this down because there was nothing we needed to do with the rational expression, 2x squared plus 64. Then minus, well, here again, I have two binomials being multiplied. So here we do have to again do box method. X minus 4 times x minus 8. Here I have x squared, negative 4x, negative 8x, negative times a negative, positive 32. Then combine like terms. Negative 8 minus 4x, or plus negative 4x, is negative 12x. Here in this numerator, that means we're subtracting x squared minus 12x plus 32 over x plus 8 times x minus 8. And I notice before I can start combining like terms, I have my subtraction here, so we do need to distribute that negative 1. Here that means I have 2x squared plus 64 still, but now minus x squared plus 12x minus 32. When I combine my like terms, here I have 2x squared minus x squared. So again, just one x squared here. No other x terms, so plus 12x. But then we do have 64 minus 32. 64 minus 32 is positive 32 over x plus 8 times x minus 8. Now, for those who continued and noticed, you could continue simplifying this expression, this rational expression here. Here, I can factor the numerator, what numbers multiply to get 32, but add to get 12, 8 and 4. So x plus 8 times x plus 4 over x plus 8 times x minus 8. That means now, how can I simplify this? What cancels out? The x plus 8. And you are left with fully simplified x plus 4 over x minus 8. Now with example 3, notice how we have a whole number. So keep in mind this is not just 7, right? But if I wanted to write this as a rational or a fraction, this is 7 over 1 minus x minus 1 over our trinomial here. So I'm going to go ahead and factor this. But notice we have a 2 here. A is 2. So that means, first off, do we have a GCF? Well, no, because 11 cannot be divided by 2 evenly. So bottoms up. We're going to factor x squared plus 11x, but now minus 80. What numbers multiply to get you negative 80, but add to get 11? Positive 16 and negative 5. However, this is not our final factored form because a was 2. That's what we multiplied by. So now make sure to divide by a, which was again 2. So this in factored form, this trinomial is x plus 8 times 2x minus 5, because again, 16 divided by 2 is 8. Negative 5 divided by 2 can't divide it evenly, so bring that bottom up to 2x minus 5. That means now I can go ahead and multiply. Sorry, I'm running out of space here. So we need to multiply by, well, if it's just 1, then I need x plus 8 times that 2x minus 5, which again will give you that 2x squared plus 11x minus 40, right? So I'm going to go ahead and write this back out, but we are multiplying this by 7. So this is really 7 times the 2x squared plus 11x minus 40, or still in our factored form, x plus 8 times 2x minus 5. For combining like terms purposes, I'm going to go ahead and distribute and multiply the 7. I'm going to distribute my 7 here. So 7 times 2 is now, so I'll go ahead and also rewrite this here. So 7 times 2 is 14, so 14x squared. 7 times 11x, 77x. And 7 times negative 40 is negative 280. Then we are subtracting from that x minus 1. So really, when we distribute that negative 1 here, we end up combining with 14x squared plus 77x minus 280. We end up combining with that negative x plus 1. So after combining like terms, no other x squared term here, so 14x squared. Then 77x minus x, 76x. Then negative 280 plus 1, negative 279. Over, I'm going to write in factored form, x plus 8 times 2x minus 5. Now this cannot be factored, so this is our final answer. So go ahead and pause the video here and try the U-try on your own. Now with the U-try, again, you have 4, which is 4 over 1. And we're adding to that this rational expression here. So really, I'm still going to go ahead and factor this trinomial, but you had 2x squared. It was 2. We have a GCF? No, because 9 cannot be divided by 2. I'm going to go ahead and bottoms up. Multiply that first to the last, a times c. We end up factoring x squared plus 9x plus 8. Now, what numbers multiply to get 8, but add to get 9? 8 and 1. So x plus 8 times x plus 1. But is that our factored form? No, because here, if a was 2, that's what we multiply by, then make sure to divide by 2. 8 divided by 2 is 4. So here I have x plus 4 and bottoms up because you can't divide evenly, 1 by 2, 2x plus 1. So this is our denominator factored form. But in this case of figuring out what our rational expression is after adding these two together, I'm going to go ahead and multiply because, again, this was just 1, and we need it to be 2x squared plus 9x plus 4, which, again, we got our factored form here, but I'm going to distribute 4 to combine then our like terms. So I'm going to distribute and have 4 times 2x squared plus 9x plus 4. Now I've got 4 times 2x squared, which is 8x squared, 4 times 9x, which is 36x, and 4 times 4, which is 16. Then plus, so we're just adding to that, x minus 7. I'm going to combine like terms now. I only have the x squared, so 8x squared. 36x, though, plus x, or 1x, is now 37x. Then 16 minus 7 is now 9. Over our factored form of x plus 4 times 2x plus 1. And again, to show y'all the reason why I'm also rewriting this in factored form is if I wanted to know what makes this undefined. Remember, we don't need both the numerator and denominator. We just need to factor. We just need to know what makes the denominator equal to 0, because then that's what would make this undefined. So that means x plus 4 cannot equal 0, and 2x plus 1 cannot equal 0. That means here when you subtract 4, you end up with x cannot equal negative 4. And here if I wanted to solve, I would subtract 1. Now I have 2x cannot equal negative 1. Then divide by 2. So x cannot equal negative 1/2. So these are the two values that would make this expression undefined. With our last example here, example 4. Again, here I notice I have my trinomial, but I now have a binomial. So again, I'm going to go ahead and factor. However, we have 2 here, so I do need to do bottoms up because there is no GCF. We end up factoring x squared plus 9x, but now plus 18. Now, what numbers multiply to get 18 and add to get 9? 6 and 3. But here, remember, this is not our factored form because a was 2. Whatever we multiply by, that a is 2, now divide by 2. So here I have x plus 3 times 2x plus 3. because here 6 divided by 2 is 3, and bring that bottom up to make 2x plus 3. That means here, if this expression factored form is x plus 3 times 2x plus 3, and we only have x plus 3 here, then what's missing? What do we need to multiply it by? 2x plus 3. Now I'm going to continue on so that we can add our two expressions here. Nothing we need to do with the first because it already has our denominator we need, x plus 1. Then plus, we are distributing 2 here. So here, 2 times 2x plus 3. Well, 2 times 2x, 4x. 2 times 3, 6. So we're adding to that 4x plus 6 over x plus 3 times 2x plus 3. Then combining my like terms here, I see I have x plus 4x, which is now 5x, and 1 plus 6, which is 7, over x plus 3 times 2x plus 3, final answer. Go ahead now, pause the video, and try this U-try on your own. In this last U-try, you have a binomial and you have the trinomial again. So I'm going to go ahead and factor. Let me erase this here for some space. But notice how you have a is greater than 1 again, you have 2. I do not have the GCF because 13 cannot be divided by 2. So again, bottoms up. You end up factoring x squared plus 13x plus 40 from 20 times 2. What numbers multiply to get 40 and add to get 13? 8 and 5. But we're not done because this was not our factored form because a was 2. So now make sure to divide by 2. In factored form, final for this trinomial here, we have x plus 4 times, bottoms up, 2x plus 5. So if this expression here, factored form, is x plus 4 times 2x plus 5, and here we already have x plus 4, well then what's missing? 2x plus 5. That is what is missing here, 2x plus 5. So that means we need to distribute 3x to this expression here. 3x times 2x plus 5. So here in that numerator now, 3x times 2x is now 6, but x squared. 3x times 5, 15x. Then minus, well, it's just the one term here because we already have our binomial here that we needed. I'm sorry, the trinomial in factored form. So we just bring down minus 5x over x plus 4 times 2x plus 5. Now, can this still be simplified? Yes, because you had like terms to combine. 15x minus 5x, 6x squared, but now plus 10x over x plus 4 times 2x plus 5.